Let's use the integral test to determine the convergence or divergence of a series. I have a summation from 1 to infinity, 1 over n raised to the 0 0.9. Then this is a p series. Okay, so this is a p series. And then the p is equals to 0 0.9 according to p series. The p is between 0 and 1. So we say the p series diverges. That is just using the concept of a p-series. Okay, can we use the integral test to confirm the same thing? In order to use an integral test, we identify the function that is f of x equals to 1 over x to the 0 0.9. And then you have to show that for x greater than or equal to 1, because n goes from 1 to infinity, you have to show that the function is continuous and positive. Is this true? The function is continuous as long as x is greater than or equal to 1. I don't see any vertical asymptote. I don't see any x value that makes the function undefined. So function is continuous and then positive. And then we have a positive base raised to 0 0.9 that is positive. 1 divided by that is positive. So this continuous is checked. The positive is checked. And then regarding decreasing, you have to take the derivative of that. X raised to the negative 0 0.9. So this one we will have to bring the power down. And then negative 0 0.9 minus 1 is negative 1.9. And this is equals to negative 0 0.9 divided by x to the 1.9. And then for x greater than or equal to 1, you have a positive denominator, a negative divided by a positive denominator that shows f is decreasing. Okay, then we are ready to go. Continuous, positive, and decreasing. Now we can use the integral test. And then we set up an integral from 1 to infinity. And then this function, 1 over x to the 0 0.9 power dx, that is equals to limit as b approaches to infinity. I have integral from 1 to b, 1 over x to the 0 0.9 dx. Okay, this one we can just use the power rule. And then what's the power rule? The power rule is you have x to the 0 0.9, right? So this one is integral x to the, okay. So this one x to the negative 0.9, negative 0.9 plus 1, you have a 0.1, and then 1 over that, 0.1. So when you take the derivative, you bring the 0.1 down, and then 0.1 minus 1 is negative 0.9. And this is 1 over 10 x to the 0 0.1, and then this one we are taking the limit as b approaches to infinity, 10 to the x to the 0 0.1 power, such that x goes from 1 to b, and then plug in the infinity. So you have 10, and then infinity raised to the 0 0.1 minus 10 times 1 to the 0 0.1. 1 to the anything is equals to 1, so this is equals to 10. So this one is always equals to 10. And then what about the other piece? The other piece, oh, this one, you know what? I will try to use a numbers. How about this? According to my notes, I use 1 followed by, let me count, 1 followed by 10 zeros. Raised to the 0 0.1 power, that is equals to 10. And then the other one I need to count because I wrote so many zeros. 18 zero. 1 followed by 18 zero. Raised to the 0 0.1 power, this is approximately equals to 63. Okay, so when n is so big, then this one will just give you an infinity minus 10 that is equals to infinity. So what does that mean? That means we have this series. Okay, I will just copy and then paste that over here. And then this series is equals to this integral. Copy and then paste is equals to this integral. And then this integral is equals to infinity. So that means the area under the curve from 1 to infinity, the area is equals to infinity, or you can say the sum is equals to infinity. So you can say the sum is equals to infinity. So therefore, the series diverges. All right, and then that is the end of this problem. Oh, before we move on, another way to do that, so do you see this step? Another way to do this is you factor out 10, and then you have infinity to the 0.1 minus 1 to the 0.1. You can do that as well. So that is equals to 10, and then you have infinity minus 1 that is also equals to infinity. All right, I prefer to do one problem in each video, so I will just end the video right there, and then in the next video, I will give you another series. So this one we have a diverge, so next one I will give you a P series, a converge, and then I will use the integral test to show that is also a converge. All right, I will see you all in that video.